ISTB presents, in association with Dhanmanjuri Community College, DM University Imphal, launching a series of educational programs, recorded online classes for undergraduate and postgraduate students by teachers from various colleges and universities. During this COVID-19 lockdown, every day on ISTB Nongin, 8 p.m. from 24th May 2020 onwards. What's for Dept? Only on ISTB Nongin.
Good morning, dear students. Today, let us discuss inventory models with shortages. So today, let us discuss economic order level model with uniform rate of demand Q to be fulfilled in constant time T, infinite rate of production and having shortage which are to be fulfilled. We have to derive the optimal order level and the minimum average cost under the following assumptions. Assumptions are as follows. Production is instantaneous, demand rate is uniform, and R be the rate of demand per unit time, Q total demand per production run, C1 inventory holding cost per unit time, C2 shortage cost per unit time, C3 setup cost per run, T time interval between successive runs, shortages are allowed, Z is the initial stock level after meeting the previous demand. So these are the certain assumptions. So in this case, shortages are to be fulfilled. So this is the diagram. So Z is the initial level of the order. This is the inventory level. At the end of time T1, inventory level becomes 0, and T be the time interval between successive run. So now this is the shortages arises. This is in time duration is T minus T1, and Q is the total demand. So level of AC is Q minus Z. So after the interval T, then again optimal level of the inventory is Z, and this is the inventory level. So at the end of time T1, then shortages again created. These shortages we have to fulfill during time T. So this is the diagram relevant to this model. So we have Z equal to RT1. R is the rate of demand, T1 is the time interval. At the end of T1, the level Z becomes 0. This is equation number 1. Next, Q equal to RT. R is the demand rate, T is the time between successive run. So now inventory Now inventory cost equal to, so this is the inventory, so half Z T1 into C1. C1 is the inventory holding cost per unit item. This is half Z, the value of T1, Z by R, Z by R. So this is equal to Z square C1 by 2R. This is inventory cost. Next, shortage cost. Shortage cost. Shortage cost. This is the shortage. So half Q minus Z. Then base is T minus T1. Then C2 is the shortage cost. This is equal to half Q minus Z T. T means Q by R. T1 means Z by R. C2. So this is 2 R Q minus Z whole square C2. Q minus Z whole square towards C2. This is the shortage cost. Therefore, total cost. C3 is the setup cost. Inventory holding cost is Z square C1 by 2R. Shortage cost is Q minus Z whole square C2 by 2R. Then average total cost. Average total cost. This is denoted by C. So 1 by T C3 Z square C1 by 2R Q minus Z whole square C2 by 2R. Then the value of T is Q by R means R by Q. C3 Z square C1 Q minus Z whole square C2 to R. This is equal to R C3 by Q plus RR cancel. So Z square C1 by 2Q plus you multiply here in the third term, RR cancel. So Q minus Z whole square C2 twice Q. This is the total cost. The minimum value of C. So for this first you find dC by dz, dC by dz. So C is a function of Z. So derivative this is 0. This is 2y Z, C1 by 2Q. So derivative this is 2 times Q minus Z. Derivative minus Z is minus 1. So C2 by 2Q. This is the first derivative. At the extreme point dc by dz equal to 0. This implies 2zc1 by 2s q minus 2 times q minus z c2 by 2s q equal to 0. So this implies 2zc1 by 2s q equal to 2 times q minus z c2 by 2s q. So we can cancel 2s q, 2 also. This is zc1 equal to qc2 minus zc2. So you bring this here, taking z common, c1 plus c2 equal to qc2. Therefore, z equal to qc2 by c1 plus c2. The value of q is RT, c2 by c1 plus c2. This is the initial optimal inventory level. Then next you find second derivative. So now d square c by dz square equal to derivative this with respect to z, twice c1 by 2q, this is minus plus, twice c2 twice q. We can cancel 2, c1 by q, c2 by q. So this is greater than 0. Therefore, c is minimum when z equal to qc2 by c1 plus c2. Let us find the value of c. Now c equal to rc3 by q plus z square c1 by q plus q minus z whole square c2 by 2s q. Let us find the value of c. So c is rc3 by q, then 2s q z square c1, q minus z whole square c2 by 2s q. So this is rc3 q, the value of c1 by 2q, the value of z is qc2 by c1 plus c2 whole square plus q minus z means qc2 c1 plus c2 whole square c2 by 2s q, rc3q plus c1 q square c2 square twice q c1 plus c2 whole square plus twice q c1 plus c2 whole square qc2 cancel, so this is qc1 square, then c2. Then taking LCM, twice q c1 plus c2 whole square, so So this is twice RC3 C1 plus C2 whole square. This is C1 Q square C2 square. This is Q square C1 square C2. This is equal to twice RC3 C1 plus C2 whole square. So from second and third term you take common Q square C1 C2, then this is C2 plus C1 divided by twice Q C1 plus C2 whole square. We can take this common, C1 plus C2 C1 plus C2, then twice RC3 plus C1 plus C2 plus Q square C1 C2 divided by twice Q C1 plus C2 whole square. So we can cancel one term. So twice Q C1 plus C2, twice RC3 C1 plus C2 plus Q square C1 C2. This is equal to, separate out, 2 to cancel. So RC3 by Q plus Q cancel, Q C1 C2 by twice C1 plus C2. So R by Q. So Q is RT, Q is RT. So R by Q is 1 by T. This is Q C1 C2 by twice C1 plus C2. So this is the optimal value of C. This is the minimum value of C. Then initial optimal value of Z is QC2 by C1 plus C2. C1 is the inventory holding cost, C2 is the shortage cost, Q is the total demand. So this is the optimal value of inventory, initial inventory level before next run. This is the optimal value of Z. Z is QC2 by C1 plus C2. So C is the total inventory cost. So today let us stop here. So in the next class I will do another model, then we will take up suitable examples. Thank you.